let's work some problems that make us think about compound probabilities using both the addition and multiplication rules. The data here comes from ACC's stock of calculators that we loan to our students. The math department at ACC keeps a stock of graphing calculators and scientific calculators to loan out to students. The current inventory is summarized in this table. Now, of course, we do have some damaged calculators. They wear out over time. We certainly don't keep them in the same place as the working ones. But for the principles of this problem, assume that I'm drawing randomly and have no idea which calculator is which. So we have 34 working TI-83s and 2 damaged ones. We have 18 working TI-84s and 3 damaged ones. And in the scientific calculators, we have 15 working TI-36s and 6 that have been damaged. When selecting one calculator at random, what is the probability that, and in question number 1, we're asked to calculate the probability that we get a TI-83 or a damaged calculator. So 83 or damaged. Well, using the intuitive addition rule, I'm just going to think about counting all of the things that are either an 83 or damaged so that I don't count anything more than once. So I definitely have these 34, 2 more, and if I want to count the damaged ones, I have 3 and 6. I've already counted the 2, so I'm not going to count it again. So on top of my fraction, I will have 34 plus 2 plus 3 plus 6. 45 total calculators meet the description of either being a TI-83 or being damaged. Alright, how many total calculators do I have? Well, I've already counted 45 there, plus 18 and 15. I find out there are 78 total calculators. So there's my probability, and I'm going to state that to 3 decimal places. 45 divided by 78 is about 0.577. Well, I'd like to go through that calculation again, but this time using the formal addition rule. The formal addition rule says that this probability, the probability of an 83 or a damaged calculator, is the same thing as the probability of an 83, plus the probability of getting a damaged calculator, take away the probability of selecting a calculator that is an 83 and at the same time is damaged. Well, if I look for the total number of TI-83s, there are 36. So 36 out of 78. Damaged calculators, let's see, 2 and 3 make 5, 6 more is 11 out of 78. And now I'm just looking at the spot that's in the overlap, and that's these two. I've counted those twice. So the probability that I get an 83 and a damaged calculator, just 2 out of 78. And if I look at that probability, I have 36 and 11, which would make 47. Take away 2 is 45 out of 78. Using either the intuitive or formal addition rules, we get the same probability. In question number 2, we are asked, what's the probability that when we draw a single calculator at random, that we get either an 83 or an 84? Alright, so again, the idea is I count the number of things that satisfy being an 83 or an 84 so that I don't count anything twice. Now the good news here is you can't both be a TI-83 and a TI-84. So I just need to count the total number of those calculators. 34 plus 2 plus 18 plus 3 is 57 total calculators. Again, I want to calculate to 3 decimal places. 0.731. Very likely. The formal addition rule here would say the probability of an 83 plus the probability of an 84. And I go to subtract, but then I realize that you can't be both an 83 or an 84. Excuse me, and an 84 at the same time. Right? You're either a TI-83 or you're a TI-84. There's no overlap. So this is going to be a 0. I'm not going to have to subtract off anything. So I just need to know that there are 36 total 83s and that there are 21 total 84s. So that should say 84. 83 or 84. 57 out of 78, which is still about 0.731. Alright, so in this next question we're going to just ask, what is the probability that we select a TI-36 or a working calculator? Well, I have 78 total calculators still. I just need to figure out how many meet this description of being a 36 or working. So I need to count the number of 36s. There's 21 of those. And then the number of working calculators that I haven't counted yet. I've already counted these 15. So I have 34 plus 18 is 52. And then I already had 21. So that's a total of 73. So the probability of being both a 36 or a working calculator is 73 out of 78, which is about 0.936. All right, let's do that using the formal rule and see if we get the same thing. Probability of 36 plus the probability of working minus the probability that I am both a 36 and working at the same time. Well, these will all be fractions out of 78 because I have 78 total calculators. The number of 36s, well, that's 21. The number of working calculators, 34 plus 18 plus 15, 67 total calculators. And then I need to know the number that are both working and a TI-36, and that's these 15. All right, so out of 78, let's see, that would be 21 plus 67 minus 15 on top, and I get a nice happy 73. That probability of 0.936. In the next video, we will talk about 2 more problems using the formal addition rule.